As always, thank you to our board for being here and helping to run all of these. And this time, thank you to OCAS for letting us use their corporate Teams account in order to host this meeting. We want to start off with a land acknowledgement. The KWSQA head office is located on the Haldeman Tract, which is land that was promised the Haudenosaunee people of the Six Nations of the Grand River, and is within the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. We are privileged to be able to live, work, and build our software quality community in such a great region. As always, our KWSQA Code of Conduct is in effect for all of our virtual or in-person events. This is always, running for us. If you have any questions, you want to report an incident, anything like that, you can always message one of us, or you can send an email to info@kwsqa.org. A quick reminder of all of the things that KWSQA has ongoing at all times. So first of all, we always have proposals open for a quality talk, so one of our monthly talks, or for a testing games if your company is interested. We also are still trying to get more mentors for our mentorship program, so please, if you are willing to, please sign up there. 2024 KWSQA memberships are basically done at this point. They are currently still available and reduced. Right now, if you have a membership, it lets you be eligible for voting. And lastly, sign up for our mailing list. 2025 KWSQA memberships will also be available for purchase soon, so keep an eye on the website and on your emails. Upcoming events. If you are a member right now, so if you have a KWSQA 2024 membership, you should have gotten an email this morning to vote for in our election. We have 2 board members up for re-election this year, so if you are a member and you've gotten that email, please follow up. We would love for you to be able to participate. And then last is our annual general meeting, which is on December 4th at 7 p.m. It is virtual. If you are a member, you will receive a link in your emails to join and attend that meeting. We'll be announcing our election results and discussing just some general kind of how the year went for KWSQA. Lastly, when we do our quality talks, we always send out a feedback survey after. If you could please submit your feedback, that would be very helpful. And there's an option when you do submit feedback to add your email, and you'll be entered in for a draw for a $50 Amazon gift card, and we will draw that name at the AGM on December 4th. All right, enough of me talking. Now let's get to why we're actually here. So today's presentation is Test Data, the Key to Robust Test Coverage. We'd actually hoped to have this at Targeting Quality this year, but we weren't able to. So we're very, very thankful that Ashok is joining us all the way from India to be able to present this to everybody today. I will hand it off.
Okay, let me share my screen first. Okay, I hope the screen is visible.
Yep, looking good.
Okay, cool. So, hello everyone, welcome you all to my talk, Test Data, the Key to Robust Test Coverage. My name is Ashok. I'm an engineering leader with TransUnion, responsible for quality assurance and engineering. I work for this company called TransUnion, and we run credit bureaus for 33 different countries worldwide. And my team is responsible for all of the testing and quality assurance for all of these credit bureau systems. Now, I've been associated with the testing world for close to 2 decades now, and my area of expertise within testing is around test strategy, leadership, customer advocacy, and test automation. And outside of work, I am a blogger. I publish my blogs in multiple external platforms, and I'm also an international conference speaker. I very recently returned from a conference in Hungary, and that's the reason why I was not able to do this talk on the conference that you had. So I'm also passionate about mentoring young test engineers who are new to their testing and quality assurance careers. And I'm also a registered mentor in a couple of these online mentorship programs as well. And in the next couple of minutes, I will be talking to you all about our team's journey of creating, reusing, reserving test data across multiple different agile teams, and some of the typical challenges that we as teams went through when we initially started thinking about test data and how do we manage this test data problem. And I'll also talk about a test data management architecture that we were able to implement within our teams, and we were able to overcome some of these challenges because of that sort of an architecture. Now, test data at a very basic fundamental level is, according to me, a bridge that connects the test ideas that we as testers think through during the design phase into actual actions that are being performed on the application under test. Now, to further explain this sort of a hypothesis, let's consider a very basic login screen. And this particular login screen now has, let's say, three basic objects in it: a username object, password app object, which is a web edit, and a submit button. Now, to test this particular login screen, we as testers can think of a happy path test case, which is how do you successfully test the success login for this particular application. So log in successfully into this application by providing valid username and valid password. Now, the test data here is the valid username and the valid password that you supply to the login screen. And that is the data that actually connects the test case, which is at the design stage, to actual actionable execution that are being performed on the application under test. So that's the bridge that connects test design to test execution. And that is very, very important, and the fundamental building block of testing itself. Now, test data is typically needed for increasing the coverage of testing. Now, there can be specific combinations of data that can activate specific areas within the application code base. And the more the combination of data that you use, the more is the chances of you able to increase the coverage of testing. And a direct outcome of this increased coverage in testing is the higher probability of testers to identify bugs or unearth issues within the application under test, which is also a key objective of testing as a craft. And test data is also needed for our automation and non-functional testing, like performance testing. And the type of data that is required for, let's say, a performance test is actually volume data. And this data is slightly different from the typical functional testing that we do. In functional testing, we don't use volumes of data to actually stress the system or performance test the system. So our test data management process also needs to cater to this type of testing. And typically, test data exists in two broad formats. The first one is synthetic data, which is data that is created algorithmically through test data creation scripts or test data generators. And these test data generators are already available as tools within the market. And we could also design our own test automation scripts to create test data. And all of this data is categorized under synthetic test data. And the key advantage of using synthetic data is that you could create as much data as you want, and you could create data which cater to the different data scenarios that we as testers think about. And that can be valid test data, invalid test data that caters to edge cases, all of the data that you think that right now does not exist in production, but you as a tester envision that this might be a problem or this might be a scenario that can happen in production in future also. All of that data can be mimicked using the synthetic test data type. The other type of data that testers typically want to use, but they are kind of they think it's a taboo to use this sort of data within testing is production test data. Now, why production test data is riskier? Because we run the risk of exposing PII information to a larger group or team of people within the organization. Now, while it has that risk, it also has a key advantage because with production test data, you will be in a situation wherein you can better mimic the real world problems that occur in production because the data that you're using is actually real world. And that is also a disadvantage with using synthetic data because synthetic data is all data that is created by us, and it is actually data that we think that can exist in production, but it is actually not the real production data. So with production data, you will be able to mimic real world customer scenarios much more realistically, and that also gives you an advantage whereby you could also now uh, expose risks that are very real and very closer to the what the customer is actually going to experience when he uses the product. Now, based on my experience working with data across multiple different teams and organizations, I've seen more or less teams go through these challenges with regards to test data management process. And we'll deep down into each of these challenges. The first challenge being typically in agile teams, what happens is testers are expected to create huge volumes of data within very short sprints of time. This is because testing as a activity itself is pushed to the fag end of the sprint. And now testers are not expected to spend a lot of time in creating the data. When that happens, the challenge is that testing timelines itself gets extended and the entire team ends up losing their sprint goal or missing out on their sprint goal. That is a key challenge with test data. And uh, as teams mature into their agile transformation, right, what happens is they also tend to become a lot more siloed. Now, with when there is a lack of centralized test data management process, teams do not have clear visibility of what data exist or does not exist within their ecosystem or within their environment. Now, when that kind of a problem with visibility starts happening, the teams that are already stuck in these agile silos, they go ahead and start duplicating the data, or they start duplicating the effort to create the data also. Instead of reusing the data, they go ahead and create data every time. And this is a key challenge that attributes to the dip in velocity within the teams itself because they're spending a lot of time recreating something that can already be reused. The third challenge is actually kind of an anti-pattern of the second challenge. While we want teams to effectively reuse data and not recreating them, we also want our testers to have the capability to exclusively access certain data records for their testing, which means that let's consider this scenario. There are two agile teams, agile team A and agile team B. Now, agile team A goes into the environment and picks up a customer record with a specific account balance. And as per their testing scenario, they expect that account balance to remain static. Now, there is also another agile team B, which is testing parallelly, and they pick up the same data record. And as per their testing situation, they now will have to post a payment transaction to that account. Now, what happens to the account balance is that that gets changed or mutated. And this results in the agile team A's testing results to become inconsistent, or they will notice false negatives that are getting reported into their testing reports. What happens eventually is that the teams need to redo their testing because they are seeing inconsistent results, or they're seeing false um, negative or false positive testing results that are being reported, which is not of value to the business. So there again, there is a there is an increased effort to redo the testing every time rather than getting testing first time right. The fourth challenge that teams typically experience with regards to test data within their ecosystem is manually creating data. Now, this is connected to the first challenge that I talked about. So already testers are pushed for time. They're crunched for time. They are at the end of the sprint. And manually creating data is not an option at that stage. They will have to have a strong test data management process that helps them to create data much more automated or reuse data so that they don't need to recreate it every time. The final challenge is around how do these third-party vendors and partners who also exist within our enterprise systems to access data. Now, any enterprise system is not a single application that needs to be tested for which data needs to be extracted. It is a chain of systems that has an upstream system where the data is created and that data flows through the downstream system. Now, the problem arises when these systems are disparately tested by different teams in different organizations even. Now, when that happens, the downstream systems or downstream teams that test these systems need to have a mechanism whereby they can access the data that is created by these upstream systems. Because they are external to the organization, that adds fuel to the fire of test data, because they now need to have a safe mechanism where they can access this data, and that access also needs to be quicker because they're also working in their own sprints and they cannot afford to wait for a longer period of time to actually access and extract data. So now that we've seen the challenges around test data that we as teams have gone through, I also wanted to talk about our success story with test data itself. And I wanted to narrate this success story through Tuckman's theory of group development, where Tuckman talks about how a team or a group transitions from a state of instability to a state of stability across these 5 different phases. So I wanted to talk about our success story equating to the phases that Tuckman talks about in his theory. Now, the first stage is forming, and while we were in this stage, we were initially creating data manually, which means that the data that was created was a lot more error prone. And also, there was an additional problem wherein we were having a lot of people dependency within our test data layer, which means that for creating specific types of data, we need specific people to exist within our agile teams. And that cannot be a ideal situation because teams are fluid, people move in and out. So we always had that problem with depending on specific people to provision this data for us. And also because at that stage, we did not have any TDM process, it was all ad hoc. There was a lot of duplication of data that existed within the teams. Because of all of these inconsistencies in our test data management process, we entered into a state of instability called storming, whereby there was a breakdown in collaboration between the teams because the teams did not have a centralized view of what data existed. This created a lot of rework in terms of data. So every team recreated the data in its own agile silos, and also the teams were not having the capability to lock data or ring fence data for their specific testing requirements. So this resulted in results becoming inconsistent, and the testing itself needed to be reworked multiple times. We then put together a test data management process, and we identified pilot teams within our agile enterprise. Before we implemented the new TDM process, we measured the baseline velocity of all of these pilot teams so that we would be able to compare this velocity once we implement it. And this stage, according to Tuckman, is called norming. What we noticed was because of these improvements that we were trying to make on the TDM layer, we noticed a significant increase in velocity of the teams. Now, the increase in velocity can be attributed to two reasons that, or two improvements that we made on the TDM process. The first one being, because we had the centralized TDM process, the teams now do not need to recreate the data every time. The effort required to create data drastically came down because they were more into reusing data. And also now the TDM process enabled the teams to exclusively access data. The testing results were much more consistent, which means that they were able to get testing first time right. So they do not need to redo their testing because of all of these data problems and the mutated data that happens across the teams or across these agile silos. Finally, we entered into a stage of adjourning whereby we implemented this TDM process across all of our agile teams. And we noticed a 30% increase in velocity across these teams. Also, what was important was we also were measuring the happiness index of our agile team. So we have a metric called happiness index where each team rates the happiness for that particular sprint on a scale of 1 to 4, 1 being completely unhappy and 4 being very happy. So this metric is measured by the Scrum Masters during the retrospectives for every agile sprint. And we noticed that surprisingly, the happiness index of teams were going up. And the reason for that is now they don't need to rework on data. Now they don't need to spend a lot of effort in cleaning up data or recreating the data every time. And the TDM process also allowed a third-party downstream systems to gain access into our TDM layer and extract the data out of it. That was also a key improvement that we noticed in our TDM implementation. Now, based on all of these challenges that we had around test data and the experience that many of us had with test data across different teams, we put together a reference architecture for test data management. And this is a Lego block architecture which can be considered as blocks, independent blocks that can be put together based on your specific test data pain points or test data requirements. Now, the left side of the architecture that you see there is the test data generator layer. And this layer consisted of two major types of data that the layer caters to, which is the synthetic data and the PII data. Now, for the synthetic data layer, we used existing test automation scripts that can be repurposed to test data generation scripts. And in certain teams, we did not have existing test automation scripts, but we had readily available test data generators, which were existing within the tooling landscape of that particular team. So we used those test data generators and created synthetic data and pushed it into a synthetic data store. For the other type of data, which is the PII data, we subsetted from production and push this prod data into a separate PII data store, which we wanted to keep these two data stores separate. And we also refresh the prod data every 4 weeks so that we get most recent data into the PII data store. The data from the synthetic and the PII data is pushed into a front-end layer through an API interface. Now, the front-end layer here acts as the central point of data management. And this is the central point of access for all of the data requesters. The right side of the architecture that you see there is the data requester layer. Now, a data requester is basically anyone who has a data request. Now, for the purpose of this talk, I have basically consider the data requester to be agile teams, but it can be even a individual tester or a developer within an agile team who has a data request. Now, the data request is basically a data scenario that has various attributes in it. For an example, a data scenario can be a customer record with an account balance of $100 and the customer uh, belongs to a particular zip code. Now, the zip code and the account balance are the actual data attributes of this particular data scenario. Now, any data requester with this kind of a data scenario will log into the front end application and basically select on the GUI screen the various attribute values. In this case, it can be account balance and the zip code. And based on the criteria that is selected on the front end screen, the TDM scripts will pull the data from either the synthetic data or the PII data store. And again, that is a choice that is keyed in on the front end by the data requester. So when the data requester keys in the attributes, he also needs to give information to the TDM automation, asking it to pull the data from either the synthetic data or the PII data that he wants. So based on all of these conditions, the data is pulled and shown on the front end screen. And now the data requester has a choice to either reserve this data or ignore the data and ask for a new data record. Now, when the data record is reserved for that particular data requester, it means that that particular data record is now made exclusively accessible, or that data record is ring fenced for that particular data requester, which means that any other data requester with that same data scenario will not be shown this particular data record. And this reservation happens for a predefined timeout period, which is a global timeout that is set on the framework. And once that timeout is reached, the data record is automatically released back into the pool. So this ensures that the TDM automation provides this capability for data requesters to both reserve a particular data record for their exclusive access. And after that reservation time is completed, it is also released back into the pool so that the other data requesters can now reuse the same data. And the API layer that you see there ensures that our downstream systems, which might be even external to our organization, can actually plug into that API layer, provided they are given valid credentials and they are given access to that. And they can similarly request for data that they require. And because they're given access directly to the API interface, these downstream systems can now plug in our data to their own TDM implementations that they might have within their organization. So by this way, we are also enabling our downstream systems to gain all of the benefits that we enjoy through the TDM process that we have implemented in-house within our organization. Now, some of the benefits that we were able to achieve through this sort of a centralized test data management process is that now our data is completely centralized, which means that we have a global visibility of what data exists within our environment. And this results in a situation wherein our agile teams, which are still agile silos in a way, do not need to duplicate data every time. So since they have that visibility, they will be able to directly reuse the data. And because the TDM process that I spoke about has that capability to reserve data records for a specific data requester, we notice that the teams are now able to get first time right in their testing results. And the effort required to redo testing is completely eliminated. The API access enables a downstream system also not to recreate data every time, but directly extract data that has already been created on the upstream layer. And the front end screen that I spoke about, that is the self-service capability of this entire TDM process. Now, data requesters no longer need to uh, wait for specific people to exist in the ecosystem for them to create data. They can directly log into this front-end UI, extract the data that they require, and the UI also automatically releases the data back into the pool so that other data requesters can now log in again on the front-end application and pull the data that they want. One other feature that I missed while I was talking about the architecture is the bulk data generation. So the front-end UI also has the capability to request for data in bulk, which means that you can either, by default, the setting is one data record, but you could actually request on the front end for multiple rows of data. For example, you could give the attributes of a data scenario and choose number of records as 100, which means that 100 data records matching that same attribute will get pulled from the backend data stores. And that can be useful for our non-functional testing, such as performance testing, where we want to simulate load and all of that. So that's about it from my end on the data side. Thank you, and I'm open for questions.
Thank you for sharing all that. I just kind of had one question. So you sort of talked a little bit more about performance. Do you do any functional testing with that test data as well, or it's a completely different sort of suite of testing that you would perform functional testing with?
I mean, the data is independent of the type of testing that we do. So for performance testing, obviously we use this sort of a process for volume generation of data. But for functional testing as well, based on the data scenarios that you key in on the front end UI, you will be able to pull data that is required for functional testing. So yeah, it's independent of the type of testing that we do.
And there's going to be kind of a follow-up question to that. Have you found an increase in quality? So you said that happiness of the team has grown. It's a little bit more efficient to generate this data. Has the quality of your test results, or the quality of the product, increased by these changes in generation of test data?
Yeah, the product quality obviously will increase because now the teams are able to test with a lot more of data. So earlier, when they were trying to do this with manually creating data, they were constrained with the amount of data that they were able to manually create. Now they have the full power of the test data management process that is there for them. So they will be able to extract much more different combinations of data that they want. And that is actually adding to the quality.
Thank you.
Any other questions?
I'll jump in maybe. So I'm very interested in the concept of like reserving particular test data records to help solve some of the challenges that you mentioned. Wondering how long does somebody typically reserve a record for? Like I was also thinking about what if there's two different teams that both want the same data at the same time? Like, do you find that you run into that kind of thing where you're like waiting in line, or is it that the amount of time that it's reserved for is so short typically that type of scenario doesn't come up?
Yeah. So right now we reserve this data for 13 to 14 hours. So 13 hours is the timeout set currently on the framework. It's a global timeout. And we have not encountered a situation wherein people are waiting in line for that specific data record. Because let's say that I want a customer record with an account balance of $100, and that data record is now reserved on my data requester ID. Another data requester, if they want the same sort of data scenario, they can still extract it from the backend data stores, just that the customer ID might be different. So there will be numerous customer IDs with the same account balance existing in a data store. So they don't need to actually wait in line. Just that they will not inadvertently mutate the data if this sort of a process is not in place.
Okay, that makes sense then. So yeah, then you wouldn't run into that case where, yeah, thank you for clarifying.
Awesome. Last call. Any other questions? All right. Well, thank you, Ashok, for joining us, especially considering how late it is in India right now. We really appreciate you taking the time. Reminder for everybody, the feedback survey will be coming out later this afternoon. So reminder that, feedback is helpful both for our presenters and for the board to make sure that you are getting the quality talks that matter the most to you. All right. And if that's all, we can give everybody back a little bit of their lunch break.
Thank you.
Thanks, everyone.
Thank you.